Hello my precious friends, I really hope that you are doing great. Welcome to our today's class. It is our second lesson on a Form 3 mathematics topic which is called further logarithm. So we are simply looking at further examples involving this particular topic. So example 5 is also a past cases equation done in the year 1998, paper 2 question number 12. It reads, find x if negative 3 log 5 plus the logarithm of x squared is equals to log 1 over 125. So in order to solve this, the first thing I'm going to simply collect the like terms that do not have x. So that simply means I'm going to take negative 3 log 5 towards the right hand side. So I'm going to remain on the left hand side with the logarithm of x squared being equal to the logarithm of 1 over 125. Then of course, if this one moves to the right hand side, it will be a positive 3, then log 5. So this will be the logarithm of x squared being equal to the logarithm of 1 over 125, then plus, if I use the third law of logarithm, which stated that if you have n, the logarithm to base c of b, this one is the same as saying simply the logarithm to base c of b to the power of n. So that means I can take these to the power of 5. So this will be logarithm of 5 then to the power of 3. So this will be the logarithm of x squared being equal to the logarithm of 1 over 125. Then of course plus the logarithm of 5 power 3, we are going to get 125. So this will be the logarithm of x squared will be equal to the logarithm. Remember, when you add, you are supposed to multiply. So this is 1 over 125. Then of course, because of the addition, I'm going to multiply based on the first law, multiplied by 125. So of course 125 and 125 will cancel out, so I remain with the logarithm of x squared being equal to the logarithm of 1. So if I drop the logs, because I'm remaining with one log on the left hand side and the right hand side, if I drop log to base 10, this will be x squared is actually equal to 1. Then of course I take square roots on both sides so that I remain with the value of x, and we know that the square root of a number is usually either plus or minus. So this one means either x will be equal to 1 or x is also equal to negative 1, because the square root of 1 will be plus or minus 1. So this is plus or minus 1. Then looking at the given question, we can determine whether the solution will be the positive alone or the positive and the negative. Now for this case, if I substitute x at this particular point, I'm going to get 1 squared will be 1. So logarithm of 1 is defined. Similarly, if I substitute x being negative 1, this square will make it negative 1 times negative 1, which will be positive 1. So the logarithm of positive 1 is also defined. So it simply means that the value of x is 1 and the value of x is also equal to negative 1, because they are both defined based on the given equation. Then we look at our example number 6, which is also a past case equation done in 1999, paper 2. Question number 6, it reads, solve for x given that log to base 3 of x then squared minus a half log to base 3 of x is equals to 3 over 2. So it's a question worth 4 marks. So if you look at this particular question, log to base 3 of x is actually common here and here. Therefore, I'm simply going to give it a letter. So I'll say let a certain letter, let the log to base 3 of x to be equal to a certain letter, maybe t or maybe k. Let me use a k or y in this particular case. So that simply means where I have log to base 3 of x, I'm going to substitute with k. So I'll substitute here with k. I also substitute here with k. So the equation will become k squared, because this was log to base 3 of x squared. So this will be k squared, then minus a half, then k, because log to base 3 of x is actually equal to k for this particular case. Then this will be equal to 3 over 2. So I want to eliminate the fraction, so I multiply through by the LCM, of course, which is 2. So I multiply this by 2, this term also by 2, this other term by 2, so that 2 and 2 cancels out. 2 will also cancel out. So I'm doing this so that I can eliminate the fractions. So this will remain to be 2k squared, then minus k, then of course is equals to positive 3. So this is 2k squared minus k minus 3 will be equal to 0. Of course, this is a quadratic equation in the form ax squared then plus bx, then of course plus c is equals to 0. So the value of a will be 2, the value of b of course will be the coefficient of k, which will be negative 1, then the value of c will be negative 3. So that means the value of x, in this case the value of x is actually the value of k, is usually given by negative b plus or minus the root of b squared, then of course minus 4ac, then divided by 2a. So this is what we are calling the quadratic formula. So k will be equal to negative b, so this will be negative 1. So negative, my b is negative 1 plus or minus the square root of b squared. Of course the b is negative 1, the coefficient of k negative 1 squared, then minus 4 multiplied by a, the value of a is 2, then the value of c is negative 3, then of course the whole thing divided by 2 multiplied by a, my a is 2. So k will be negative will give me plus 1, then plus or minus, I feed this on my calculator, so open bracket negative 1 squared, then of course minus 4, then multiplied by 2, then multiplied by negative 3, I'm going to get 25. So square root of 25, I'm going to get 5, then divided by 4. So it means either k is equals to 1 plus 5, then divided by 4, of course, which will be equal to 6 divided by 4, which gives us, if you simplify 6 divided by 4, you are going to get 1.5. So this is 1.5. So the other possible value of k, so or k will also be 1 minus 5, then divided by 4, of course, which will give us negative 1, because 1 minus 5 you are going to get negative 4, then negative 4 divided by 4 you are going to get negative 1. So from there, remember the question wanted us to find the values of x, not the values of k. We are going back to this particular equation here. We had said we are letting log to base 3 of x to be equal to k, but the first value of k is 1.5, so this is equals to 1.5. So to find the value of x, I'll simply change this to what we call the index form. So this will be 3 to the power of, so in this is the logarithmic notation, so in index form it will be 3 to the power of 1.5 will actually be equal to x. So you simply take 3 to the power of what is on this side should be equal to x. So of course this will give me x as being so 3 to the power of 1.5. The answer will be to 4 significant figures, I'm getting 5.19196. So this is correct to 4 significant figures. Or the other possible value will be the log to base 3 of x is equals to k. The other value of k was negative 1, so this is negative 1. If I change this to index form, I'm going to get 3 to the power of negative 1 being equal to x. So x will be 3 power negative 1 will give you a third. So 3 to the power of negative 1 is the same as saying 1 over 3, or 0.3333 recurring. Then we need to determine whether both values represent the value of x. So x is 5.196, x is also 1 over 3. So since both values of x are positive, and we know that the logarithm of a positive number is defined, it means x is 5.196 and x is also a third. Therefore x is 1 over 3. So x will be a third and the other value. So x is 1 over 3 and x is also equal to 5.196. So both values are defined. Then we look at our example number 7, which reads that find the value of x that satisfies the equation log into bracket x plus 5 is equals to log 4 minus log into bracket x plus 2. So it's also a past equation done in 2000 paper 1 question number 5. So applying the laws of logarithm on the left hand side, I'll simply have the log of x plus 5, then of course being equal to, when you subtract you have to divide, so this will be log then into bracket 4, then of course divided by x plus 2. Whenever we subtract in logarithm we have to divide. So this will give us, remember when you remain with one log on the right and the left hand side, you simply drop the log. So this will be x plus 5, which should be equivalent to 4 divided by x plus 2. Then of course these are quadratic, so I want to cross multiply so that I get the quadratic. So this will be x plus 5, then of course it will multiply with x plus 2, which should give me 4 multiplied by 1. So if I expand, I'll get x into x plus 2, then plus 5 into x plus 2. So this should be 4 times 1, I'm going to get positive 4. So this will be x squared, then plus 2x, then plus 5x, then plus 10 should give me 4. So this will be x squared plus 2 plus 5, I'll get 7x. Then of course 10 minus 4, I'll get positive 6, then will be equal to 0. Then I solve for the values of x. If I use the quadratic formula, the value of x will be negative b. You simply compare with ax squared, then plus bx, then plus c, so that the value of a will be 1, the value of b is positive 7, then of course the value of c will be positive 6. So x will be negative b, which is negative 7, plus or minus square root of b squared, which is of course 7 squared, then minus 4 times a is 1, then c is 6, then the whole thing is divided by 2 times a. So that means x will be negative 7 plus or minus, let me use my calculator. So this will be 7 squared minus 4, then multiplied by 1 multiplied by 6, I'm going to get 25. So of course the square root of 25 will be 5, then divided by 2. So it means either x is equals to negative 7 plus 5 over 2, which will give us negative 7 plus 5, you are going to get negative 2. If you divide that by 2, you are going to get negative 1. So x is negative 1, or the other possible value of x will be, or x is also equal to negative 7 minus 5, then divided by 2, which will give us negative 7 minus 5, you get negative 12, divided by 2, you'll get negative 6. The other possible value of x is negative 6. Now from these two values we need to determine whether all of them are defined. If I try with negative 1, if you substitute negative 1 here, this will be negative 1 plus 5, which will give you positive 4. So logarithm of positive 4 is defined. Then if I substitute x as negative 1, this will be negative 1 plus 2, which will be positive 1. Logarithm of positive 1 is defined. So that means x is equals to negative 1, so this solution is defined. If I substitute x when it is negative 6, I'll get negative 6 plus 5, which will be negative 1. Logarithm of negative 1 is not defined. Then if I substitute here, this will be negative 6 plus 2, which will be negative 4. Logarithm of negative 4 is not defined. Therefore it means that the only value of x will actually be negative 1, because negative 6 is not defined as a solution. Then we look at our example number 8. So we look at our example number 8, which is also a past case question done in 2001 paper 2 question number 8. It reads, the log of x plus 24 minus 2 log 3 is equals to the logarithm of 9 minus 2x. It's a question worth 3 marks. So we are told to solve the equation. So applying the laws of logarithm, if you want your work to be easier, you start by eliminating the negatives on the question. So I'll take this one to the right hand side so that it becomes a positive. So this will be logarithm of x plus 24 will be equal to logarithm of 9 minus 2x, Then of course if it moves to the other side it will be positive 2, then logarithm of 3. So this will be the log into x plus 24 is equals to log into 9 minus 2x, then plus, so of course from the third law of logarithm I can take this one to the power, so this will be log of 3 to the power of 2. So this is log 20x plus 24, then is equals to the logarithm of 9 minus 2x, then plus the logarithm of 9, because 3 power 2 will be 9. So this will be the log of x plus 24 is equals to the logarithm, then into bracket, of course we'll be multiplying these two, so this will be 9 minus 2x, then I multiply with 9, which is the same as saying 9 into 9 minus 2x. Remember, whenever you add you have to multiply. So if I drop the log, because I am having one log on the right hand side and one log on the left hand side, if I drop the logs, I remain with x plus 24 being equal to 9, then into 9 minus 2x. So this is x plus 24 will be equal to 9 by 9, I'll get 81. 9 by negative 2, I'll get negative 18x. Then of course I'm simply going to collect the like terms together so that I'll have x. If 18 moves to the other side it will be positive, so positive 18x is equals to 81. If 24 moves to the right hand side, of course it will be negative minus 24. So x plus 18, I'm going to get 19x, so 19x is equals to 81, then minus 24, I'm going to get 57. I'll get 57. Therefore x will be 57, then divided by 19. Therefore my value of x will be 3. So x will be equal to 3 as my solution. Then we move to the next example, which is example number 9. So our example number 9 reads: solve the equation log to base 10 of 6x minus 2 minus 1 is equals to log to base 10 of x minus 3. It's a past case equation done in 203, paper 2, question number 5. So the first thing we are going to do, we'll break this one down. So it is always easier to work with the positive values. So let me take this one to the other side so that it becomes positive. So I'm going to have the logarithm to base 10 of 6x minus 2, then of course is equals to, so this will be log to base 10 of x minus 3, then of course the 1 will become positive, so this is plus 1. But we know that if you take log to base c of c, the answer will be 1. Therefore, since everything is to base 10, it means this one is the same as saying log to base 10 of 10. Therefore I'll substitute it here so that I have log to base 10 of 6x minus 2 being equal to log to base 10 of x minus 3, then plus, so 1 is the same as log to base 10 of 10. So log to base 10 of 10. So this will be log to base 10, then into, of course, 6x minus 2 is equals to log to base 10, then of course this will be into, when you add you are supposed to multiply, so this will be x minus 3 then multiplied by 10, so this will be 10 into x minus 3. Then this will give us, of course I'm going to drop log to base 10 since I have one log to base 10 on the right and the left hand side. So if I drop log to base 10, I'll remain with 6x minus 2 being equal to 10 into x minus 3 into x minus 3. So this is 6x minus 2 being equal to 10x, then minus 10 by 3, I'm going to get negative 30. So this will give us negative 30. So negative 30. Then if I collect the like terms, I'll take the 6x to the other side, then I take 30 to this other side. So I'll have positive 30 minus 2 being equal to 10x minus 6x. So this will give me 28, 30 minus 2, 28, being equal to 4x. Then of course, if I divide through by x, my x will be 28 divided by 4, of course, which will give us 7 as the answer. 7 as the answer. Then we look at our 10th example, which is also a past cases equation done in 2004 paper 2 question number 5. It reads, evaluate without using mathematical tables the expression 2 log to base 10 of 5 minus a half log to base 10 of 16 plus 2 log to base 10 of 40. So applying the laws of logarithm, I can take this one to the power. I can also take a half to the power. Remember, when you take a half to the power, the sign remains. The sign is for the whole term. You only take the half. Then the negative will remain to represent the term. So this will be log to base 10 of 5. So I'll take 2 to the power, then minus log to base 10. Remember, when you are taking this, you simply take the half, but the sign remains for the term. So this will be 16, then of course to the power of a half. 16 to the power of a half. You pick the half, but you leave the negative to represent the sign of that particular term. Then of course plus, so I'll also take 2 to that power. So this will be log to base 10 of 40 to the power of 2. So this will be log to base 10, then of course 5 power 2 is 25, then minus log to base 10. Now remember, 16 can be written as 2 to the power of 4. If you check the factors of 16, by 2 8, by 2 4, by 2 2, then of course by 2 1. So 16 is 2 to the power of 1, 2 3 4, 2 to the power of 4. So this can be written as 16 is 2 to the power of 4. Then of course we have a half on the same power, then plus log to base 10 of 40 squared. So if you take 40 times that is 40 squared, should give you 1600. So 40 squared is giving us 1600. So this will be the log to base 10 of 25, then minus the log to base 10 of course 2 will go here 2 times, so that I remain with 2 to the power of 2, of course, which will be 4. So 2 power 2 will be 4, then plus the log to base 10 of 1600. Then I can factor out log to base 10. So this will be log to base 10, then into, I apply the laws of logarithm. When you subtract, you have to divide. So this will be 25 divided by 4. Then when you add, you have to multiply, then multiplied by 1600. So this will give us log to base 10. Let me feed this on my calculator. 25 divided by 4, then multiplied by 1600. I'm going to get 10,000. So this is 10,000. Then remember, if you find the factors of 10,000, 10,000 is the same as saying 10 to the power of 10 to the power of 4. So let's just show it here practically. So this will be, if you look at the factors of 10,000, so if I start by 10, 10 will go here 1,000 times, then 10 will go here 100 times, then of course 10 into 100 10 times, then 10 into 10 1. So 10,000 is the same as 10 to the power of 4. So this is the same as saying log to base 10 of 10 to the power of 4, which can be rewritten as 4 log to base 10 of 10. But we know that the log to base c of c should always give you 1. So this is the same as saying 4 multiplied by 1, because log to base 10 of 10 is actually 1. So the final answer will actually be equal to 4. So thank you very much for accompanying me until the end of this particular lesson. Until next time, this is Kind Tuition Academy.